All right, kiddos. So now we're going to be working on, well, let's preface that with, we've been working on quadratics and how to factor them and how to solve them by factoring, how to solve them by using the square root method, and also solving them by using the quadratic formula. Okay, and now we're going to figure out what those solutions actually mean in the context of graphing. Okay, so I've shared this Word document, Quadratic Graph Discovery, with you in the files in our teams so that you can have that and follow along if you so desire. And I also, you can see, have Desmos pulled up because that's going to be kind of how I like to teach this as sort of a discovery type of method so that you can see how the factored form and the solutions relate to the actual graph. Okay? So what we're going to do first, I'd like us to look at this first equation. It's already in factored form for us. So of course we would set it equal to 0. We know that. So this is the same thing, you know, as x minus 3, x minus 4 equal to 0. And if I were to ask you to solve that, again, you would split each one. So x minus 3 would be set equal to 0 using that 0 product property. And then x minus 4 would be set equal to 0. And my two solutions would be x equals 3 and x equals 4, if I'd ask you to solve it. Okay? Now what I want you to notice is what happens when I type that equation into Desmos. So I'm just going to switch it around and say y equals, just for giggles, you don't have to. So x minus 3, parentheses, x minus 4. Okay, let's look at this. So let's blow it up just a little bit. All right, and I want us to pay special attention to the x-intercepts, okay, and also the y-intercept. Okay, and so the x-intercepts, again, these are called solutions. They're called zeros. They're called roots, x-intercepts, all those things. Okay, so my two x-intercepts in this case, if I hover over it, one of them is going to be 3, 3, 0. Golly gee, 3, 0. And then my other one, if I hover over it, is 4, 0. Okay, and it makes sense that the x-intercept would have a y-coordinate of 0, right? Since it's not up or down, it is right on the x-axis. Look at some similarities here. Okay, now y-intercept. Let's look at the y-intercept. That is 0, 12. And then last thing I want you to look at, this one's not quite as important at this time. So actually, you know what, we're not even going to talk about the vertex today. Okay, and then I want us to sketch the graph. So over here, let's go ahead and just put a rough sketch together. The big things that I want you to worry about plotting on here are the x and the y-intercepts. So one of the x-intercepts is going to be at 3, come on, work for me, 3, 0, 1, gee whiz. One's going to be at 4, 0, and then I'm just going to label this, make it easier. So 0, 12. So all right, so we know it's going through. It's not a pretty parabola at all, but the Desmos one can show you what it really looks like. Okay, let's go ahead and label these x-intercepts, 3, 0 and 4, 0, so we don't forget. Okay. All right, so now let's look at and kind of think about this too. So now let's look at this next equation. I'll even do it in blue. So if I were to ask you to solve this one, you would split it apart again, right? And you would have x plus 3 equals 0, and you would have x plus 4 equals 0. So your two solutions would be x equals -3 and x equals -4. Let's consider what that might look like then as a parabola. So x plus 3, x plus 4 equals y. It's even in blue. How about that? All right, so let's move it over here. All right, and let's hover over, because again, this this graphic organizer that I created here asks for the x-intercepts, or the zeros, or the solutions, roots, all those things. Same thing. One of my x-intercepts is at -3, 0. and my other one is at negative 4, 0, and I'll hover over that. Huh. So my solutions are the same things as my x-intercepts, right? And we kind of talked about that, and that's what that means. Okay, now let's talk about the y-intercept. Okay, it's also at 0, 12. So let's go back and fix that, okay? I wonder where that 12 comes from. That's interesting. Let's not worry about the vertex. Let's draw our little graph here. So I have one here, here, and let's just say this is up at 0, 12. And we're gonna, it's not pretty, but you get the idea, okay? And it's opened up like a smiley face, right? Okay. Alrighty, so now let's go on to the next one. So I'm going to erase these two over here. Okay, and so my next one is x minus 6 and x plus 5. Alrighty, let's see. So if I were to ask you to solve this, okay, you would probably want to factor it. You could use the quadratic formula, but you'd probably want to factor it. And you would say, well, I need factors of positive 5 that have a sum of negative 6, right? Well, I know that it's going to be negative 5 and negative 1. So x minus 5, parentheses x minus 1 equals 0. If you were to solve that, you get x equals 5 and x equals 1. Okay. All right, well, let's see what... Let's just type it into Desmos, just as is originally given to you, okay? Golly gee. So if I were to type this into Desmos, x squared minus 6x plus 5. And you don't even have to type in the y, you can put that in there if you want to. Okay, I'm going to shrink this a bit. Okay, get a little bit bigger. Alrighty, so let's see where those x-intercepts are. Well, one of them is at 1, 0. Huh, that was one of my solutions, wasn't it? And the other x-intercept, 5, 0, again, one of my solutions. Okay, now let's look at the y-intercept. Huh, this is 0, 5. Look at this equation here. Where do you think that 5 came from? Look at this one. Where do you think the 12 came from? And this one, where do you think that 12 came from? Interesting. We'll talk about that some more. All right, so then not going to worry about the vertex. Let's sketch this really quickly. So here's a 1, 2, 3, 4, 5. Let's put a couple points there. It likes to erase them on me. And then up at 5. There, it already erased. 3, 4, 5. So it goes through here, here, and then the vertex, you could write it down if you wanted to, is 3, negative 4. But I'll just estimate. Okay, and these go on infinitely, right? Okay, good. All right, so hopefully you're seeing some things here. Alrighty, now what I want to do though is think about, let me erase these couple things, and it's probably going to make it go wonky. Okay, not wonky yet. Oh, let's erase this guy too. Okay, now let's think about this next one. Now a is not 1 in this next one, so I need to use that AC method. So let's erase that. All right, so I need to find factors of negative 7 because I've multiplied the a and the c together, right, to get my magic number that have a sum of positive 6. Okay, well, I think that'll be 7 and negative 1. Would you agree? Okay, so that's the same thing as x squared plus 7x minus x plus 7, right? And so then I factor out my x here, I get x plus 7, factor out my minus 1 here. I made a boo-boo. Boo-boo. Oh, it's negative x squared. So this is minus 7. There we go. Let's erase. So if I factor out a negative, let's factor out a negative x, okay? Then it would be x plus 7. Just kidding, minus 7. Julie Elizabeth. Trying to write too small. We'll blame it on that. How about that? All right, x minus 7. And then you're going to factor out your negative 1, and you're going to get x minus 7 over here. Okay, so your two factors are going to be negative x minus 1 and x minus 7. I'm going to set that equal to 0. Okay, I'm going to go on to the next page a little bit, because if I were to ask you to factor, or to solve by factoring, you would do negative x subtract 1 is equal to 0 and solve it, and an x minus 7 is equal to 0 and solve that. This is going to be negative x is equal to 1, so x is equal to negative 1. This is going to be x is equal to 7. Let's see how that comes into play in the graph. So if I were to graph what was originally given to me, negative x squared. Oh, got a frowny face. Okay. Plus 6x plus 7. You could put plus y or equals y if you want to. You don't have to. Okay. So let's see here. So let's look at the x-intercepts. Wow. Okay. So this, my first x-intercept is negative 1. You can write them in either order. Negative 1, 0. My other x-intercept, if I hover over this, is 7, 0. Are those the same things as our solutions? They sure are. Okay. What about this y-intercept? 0, 7. All right. And then don't worry about the vertex for now. And then let's graph this one. This one's different, right? This one's different because it is a frowny face, whereas the others were happy faces. So this is 1, 1, 2, 3, 4, 5, 6, 7, and this is it. 7. Okay, this isn't perfect, guys. Just give me some leeway on it, okay? All right, so it looks like that. But this one is frowny. This one is smiley. This one is smiley. And this one is smiley. What's the only difference in these four equations that we've done? Only one of them had a negative a term, right? So if you have a negative a term, it means you're going to get a frowny parabola. If you have a positive a term, that means you have a happy parabola. Okay? Alrighty. So there's lots of practice ones that you can certainly do on your own. Okay? But now what we're going to be doing is looking at those relationships and those examples that we did and coming up with some ideas and discoveries. So let's see, relationships between the equation and the factors and what you wrote down for x-intercepts. Okay, so I think we already talked about this. I'm going to blow this up just a little. Actually, I'll make it